we believe that LLMs are the future. They are not only the best model to use right now, but because everyone is working on them, they're just going to keep doing better.
Welcome everyone to Slator Pod. Today on the podcast, we welcome João Graça. So João is the Chief Technology Officer and co-founder of language operations platform Unbabel. Hi João, and thanks so much for joining today.
Hello, good morning. Thanks a lot for having me.
Where are you recording this from today, other than the booth?
I'm recording from our office in Lisbon, Portugal.
All right. Before we go into the discussion around LLMs and machine translation, that's the focus of today's this discussion. Just tell us a bit more about what motivated you to co-found Unbabel and kind of the experience in the early days, just a bit of context for our listeners.
Yeah, so I have a background on natural language processing, and so I did my PhD on learning, unsupervised learning, and machine translation. Vasco also comes from the same area. And we and the rest of the co-founders of Unbabel realized we really wanted to work together. So we've been in a startup before that failed. And we started looking about, okay, what is the problems that we can address with our knowledge? And we've kind of landed on this issue that people that we knew that were renting Airbnbs were actually struggling with language. So if someone from Germany tried to rent an Airbnb, they didn't know how to speak German. They couldn't use Google Translate because the quality was not good enough, so they're kind of stuck. And we started thinking, well, can we do something about it? Can we try to combine machine translation, because it's actually very useful. This was like 10 years ago. But at the same time, just have a human to say, is the translation good or not? Can I send this to the recipient or not? And we started from there, and we got some initial validation. And then from there, we say, well, instead of just saying yes or no, what about if they actually correct the errors and like to post machine processing? So that's pretty much how we started. So we just embarked the five of us on building the prototype of like the freelancers, the MT part, the web order, so people could send content, which was really interesting. And then we got to Y Combinator, we started scaling. At that point, we decided, okay, we're doing translation. So we were a bit naive, we thought translation as a whole. And suddenly what we realized is like we're being pulled apart from all different directions. Like every translation project had different like file processing, different requirements, different quality expectations. And we realized it was very hard to build a product in that scenario. We ended up having a service company that was basically, treating every small project as their own special child. And that was not our goal. Our goal was to build a product. So in that period, we kind of made a hard decision to focus on one vertical. We listed everything that we're doing. Two came up that were like the best fit for us. One of them was customer service. And we went all in on customer service. So we actually fired a bunch of our customers in a sense like we were not going to work with you. And we said, okay, let's have a solution for customer service where the idea is like you go to Zendesk or Salesforce and you just install Unbabel and then your agents can speak every other language. And we can do it at a very fast pace. So MT was not enough, but we could have this crowd of humans that produced the quality that was fit for purpose and that could turn around in 10 minutes. And that was kind of like, okay, if we want to build a translation layer, we have to do it like use case per use case. That's how we're going to get to the translation layer as opposed to try to solve everything from the start. And for a long time, we started growing in customer service, kind of dominant on that market. There was not a lot of competition from translation agencies. And then a couple of years ago, I said, fine, so this problem is like done. We're solving it, we're growing. Now let's go to other verticals. And we start explaining to other use cases on translation. And there we start doing more of an M&A approach. And we already acquired 2 companies and basically push the customers to our platform and use the product to improve. And this is where the concept of the language operations platform came, like the platform where you can manage all different pipelines per use case and connect with AI and so on.
I mean, generally a challenge that many people underestimate when they look at the space kind of from the outside. Initially, like the complexity, use case, vertical, text type, content format, speed, everything. So it's, I see where your decision to kind of focus initial use case and expand came from. Today, we want to talk about large language models, how they're impacting or shaping now machine translation. And Unbabel has been contributing very heavily to MT and now MT focused LLM development, also through a lot of open source projects. We're coming across a bunch of your research papers. Can you just walk us through some of the key contributions in the last, 2, 3, 4 years? I think you've been doing this for a long time now, the kind of publishing, research, contributions, open source work.
It's good to start this by explaining the genesis of Unbabel. So I was coming from academia, Vasco had been in academia. So we have a very strong connection with research institutions. I was a professor at the biggest engineering school in Portugal. And basically, when we started Unbabel, we realized there's a bunch of problems that we need to solve that there's no solution. It requires research. Like MT is far from being solved. QE haven't started. Even like editor assignment. And so from the early days of Unbabel, we're 5 of us, and we're already sponsoring a master degree on text anonymization for translation. Like, what's the best way to anonymize for translation? And we always had this strong connection, and we always felt that academia could also be a way for us to expand our initial team. So we could basically work with academia and give something that was good for academia, but at the same time leverage and get resources to work on our problems because they were research problems. Really early days, we're like 8 of us or 9 of us, and we hired André Martins, which is also a professor at IST, a renowned researcher, has to be VP of research because I was doing a lot of the engineering part. And so the ratio of PhDs in NLP versus the Unbabel was always huge. And then we got Helena, there's like a research on linguistics. So from the get-go, we knew that to tackle the problem, we need to do research. And so we started on MT, so basically on Moses, like the question, like how can we basically make Moses better for specific domains? Then when Neural came, we jumped into Neural MT very fast, and we started contributing to the Marian MT model from Marcin. Marcin was interning at Unbabel. We started contributing for that very early days in PyTorch. And so that's been the journey on MT, and now with TowerLLM. But on the same side, we also started contributing a lot for QE. And on QE, there wasn't like an open source tool that people could use. So we started doing like QE, the framework, and now Comet, the framework. And really our vision is that, first of all, we believe that research should evolve. So we should contribute back to the community so that we can work on top. So all our models, source toolkits, are open for research. Some of them are not open for commercial use because we can't give everything to our competition, but they're open for research. And we believe that's profitable for everyone, for the community and for us, because we can also learn from the people that work on top of our tools.
Yeah, it's kind of rare that you're more the exception than the rule in terms of the open source approach there. Can I just dwell on just the term NLP? How has this changed in the past 2 years? Like with so many previously very narrow and hard to solve use cases now being kind of opened up by LLMs. Like, has it changed completely? Is NLP now still a thing in 2024, or like, what's your take on this?
I think it's still a thing. We have much better tools. So I think NLP is about defining a set of problems, and then there's methods to solve them. So the problems are still there. Some of them are further ahead, but for instance, you still need to have like proper validation sets for each problem. There's new problems that you now can tackle. Now, what happened to LLMs? Well, it's especially like the current trend of LLMs, like instruction-based LLMs, is that they solve a couple of issues. So they have very good extractions on text and words and sentences. And they have a way that you can pass declarative information via requests. And so before, for instance, like the task of transcreation, it used to be something that we were trying to work on the context of cultural awareness. So basically take a text and make it like appropriate to the Japanese culture. This was a super hard task to do before LLMs, kind of ChatGPT like came out. It's very hard like how to do the input output, how to get data. And right now that's a prompt away from a good LLM that you can do really good. So that made it much simpler to start getting these MVPs for a task, and you can always make it better. But you still need a lot of knowledge. You still need a way to evaluate. I think the other thing is like it kind of democratize building AI models. So before, if you're a linguist, the only way you had to contribute to an AI model is to create data sets. And basically you needed engineering to actually come up with an algorithm to use those data sets to produce the output. Right now we have linguists producing models by picking the right prompts with RAG, doing the data sets, and it's a full complete model. So it kind of made it more available for domain experts to build everything themselves.
Let's dwell on RAG for a second. In a recent webinar when you launched TowerLLM, and I want to get back to TowerLLM as well, you walked people through the RAG, and you said kind of 4-stage approach. First, look for similar sentences in the TM, get context, get terminology, get style guide, and then do all this kind of runtime in production. Can you just elaborate on this a little bit more? Because we're hearing RAG now much more often than we did, 6 to 12 months ago, of course.
I mean, I think RAG is a super powerful tool for customization of a model. So before, what you could do is you could basically do some fine-tuning on a model, and that's what we've been doing at Unbabel for ages. And then when you want to pass terminology, you have a really hard time how to use terminology. So there was like the concept of factors, But that thing never really worked well. Now, with LLMs, you can pass like this declarative information. You can declare that translate this, knowing that the style is formal, that the terminology is this one, that the style guides are blah, blah, blah. And the model can actually use this information to enforce it during decoding. Now, it's not a 100% guarantee that it will enforce. And there is still kind of research on how to make models follow reg better. So there's kind of like the same prompt given to different models does not yield the same results. And I don't think it's because of the underlying model. It's like how well is the model trained for reg. So that's a research direction. But in a lot of cases, you can just declare what the customer wants and the model will follow it. Because I think the essence is the underlying model, like the underlying LLM, is super powerful. So think about it like it potentially has all the information there exists there. So the game now is add more information. Like on old models, you had to add fine tuning for them to see new words or to have new information. Assume that everything is there on this base model. It's more a question of like how do you pick the right information from this huge thing? And I think reg is super powerful.
What's the challenge like in production, doing this like runtime, like sync, like with millions of words? Is that research versus like in production, like big problem?
Yes, there's a lot of engineering problems. And I think that's what taking companies time to basically launch these things in production. So one thing is saying, I have ChatGPT, you can put the prompt, I have LLMs. That doesn't solve the customer problem because where are they going to get the example? So there's several steps. So first of all, if you want to use like TMs to basically give context, to give like proximity, you need to implement a vector database that you can search and it has to be ultra efficient. And so that you basically, for every request that you get for MT, you can go search the similar ones and fetch them on time. So that is one part. Terminology, I think it's easier. If you have access to terminology, just put it there. If you want to do context, basically, if your pipeline is set up to do sentence by sentence translation, and so you have all your system that all it does at some point, it iterates over sentences and it sends each sentence somewhere and goes through different steps. Now you have to change it to say, no, now I want you to pass the paragraph or the entire document. So there you have to change the underlying infrastructure. The second part is you need to know how to run this in production. So you have two options. Either you call ChatGPT API and then you're safe. OpenAI is running it for you. Or if you're running, you have to know how do you run these huge models. How do you scale down to zero when you're not using because they're very expensive? You have to play with latency versus cost, the trade-off. So there are some challenges. Now, once you overcome them, I think the outcome is positive.
And why would you not just go to ChatGPT or OpenAI? Like, what's the major advantage if you have solved all the kind of further downstream problem or for the customer? Like, why would you not just rely on them and having like one ability yourself?
So I would say that every company should do that first. Either ChatGPT or Claude, like the latest Claude seems to be state of the art from the closed source models. So I will do that, and we did that. We use these models to test. I think that once you have that part figured out, then the question is, do you believe you can get better results than these models? Yes or no? And our answer is yes. Do we believe you can make them cheaper? Because if you're working on translation, then you're basically being paid per translated word. So any margin you can get on the word becomes important. And the first is, do you think you have an advantage when selling to the customers because of privacy issues? And we also think is yes. So when we did the analysis 1.5 years ago, and this is when we had to make a call at Unbabel, are we going to go all in on LLMs or we just call it quit and just use ChatGPT on top? We analyzed those three things. Some of them were beliefs, but these were the three things we think you could do better given our know-how. And we decided to go all in.
So where does that leave, like the whole LLM, like machine translation via LLM or having some LLM layer, like where does that leave the maybe 3 years ago narrower machine translation approach? Like, is it just phasing out? Does it have a future in certain scenarios? Is it not something you want to pursue?
Well, we discontinued completely at Unbabel. So we had this huge initiative a couple of years ago of having this multilingual neural MT. So basically one model covering several languages, weak factors to cover technology. So pretty much like state-of-the-art technology. We believe that LLMs are the future. Like they are not only the best model to use right now, but because everyone is working on them, they're just going to keep doing better. So the amount of people that are working on improving everything on an LLM, like decoding, using a RAG, versus the amount of people that are trying to improve neural MT is disproportional. So it's like neural MT is going to fade away. And it's not as powerful as a model. Now, There are still challenges on LLMs, like how small can they be so that they're cheaper and most cost effective? If they're smaller, can they still do multiple language or RAG? So there are still some questions. I think it's kind of like the same transition we saw from phrase-based to neural MT. If you go to like Google and you search some points, you still see a lot of people when neural MT was already better, finding some niche examples where the ultra customized phrase-based was still better because there was less data or because the domain was very niche. Yes, you can still find an example where neural MT is going to be better. I think it's a question of 1 year. I think people are still in the process of doing this engineering to run them on production. And until then, they're basically saying that, oh, it's still neural MT, just until they catch up and then they switch and come out with something new. That's my view.
Yeah, and one of the caveats that I heard 6 to 12 months ago was price, but then we all read the intent to report, and you also commented on this recently, that price seems to be no longer an issue.
Yes, which is very interesting because if you think about it, there's no way an LLM can be cheaper than a neural MT system if you just think about the compute power, because, in theory, the cost comes from model size. And you can have a neural MT system as big as an LLM. Like, in fact, the no language left behind is as big as these big LLMs. But most neural MT are smaller. So the fact that the LLMs are coming cheaper is either because people are overpricing the MT or because someone is sponsoring the LLM to make it cheaper. But right now, if you just compare like Google Translate versus ChatGPT for translation, ChatGPT is cheaper. Or ChatGPT versus DeepL is like a third of the price. So that is the reality. I don't think I don't think there's a reason on the infrastructure side, but that's what's happening right now.
So with this in mind, you decided to build TowerLLM. And so that seems like it was not a decision taken 2 years ago when this all came out, maybe like a year ago, and then just give us a bit more background to it.
It was actually 2 years ago. So we've been working with LLMs, not this instruction-based, but large language models for some time. So Comet QE is based on an LLM. Our previous NMT was based on an LLM. We had some struggles on like how to deploy these things to production. Again, because of the size of the model, it required GPU on production, but we're running them. And once ChatGPT came out, the question that I got from all our investors was, is this going to kill Unbabel? Like, what's the future for the language industry? And we spent some time thinking about that, and we said, well, these models are not state-of-the-art. They are going to become, but they bring a lot of advantage. They allow you to do a lot of tasks much simpler, like automatic bust editing, source correction, QE, yada, yada. And we think we have a card to play because we have the know-how. We've been playing with these models for a while. We have an amazing research team. So you don't find a lot of people that know more about LLMs and NLP than the team that you have at Unbabel. Like, we have really good people from academia working with us. We have a group of linguists that is really good at like curating data. And we know that data is kind of like the secret sauce to make these things work well. We have QE. So QE is like the thing that allows us to like massively curate the translation data. So we kind of had all the ingredients to say, okay, we can build an LLM that is competitive on this translation domain where QE is actually differentiating. Not a LLM that is going to compete against ChatGPT for answering bar exams. Like that's not our goal, but that can be actually better on cost, speed, and quality for the translation industry and open the door for other tasks that before was super hard to solve that we can now solve. And that is super interesting. And that's how we decide, okay, how much money do we need? What's the team? And you say, okay, research team, you guys go all in into TowerLLM. And after a year something, we have this TowerLLM come out, which I'm very proud of.
How does that work? So, I mean, I had a screenshot that I saw on one of the webinars. You have phase 1, 2, and 3, right? First phase was data coverage, train on curated data, and then fine tune. But like, okay, you're saying we're building TowerLLM. Like for the layperson, the informed layperson, what does that mean? Like, where do you begin with this? How does that work?
I'll tell you, there's 2 initiatives going in parallel. So this version of TowerLLM has the following recipe. You take an open source large language model. Think about Llama 3, Llama 2, Mistral. So basically what this does is like it's a large language model that already created this word representation. So it has all the knowledge there. It's kind of like this magic box. Now what these open source models normally have is like they're not very multilingual because they're not trained to be multilingual. So they're mostly having English data. They never tell the model what is a parallel sentence to another one. So they do get some multilingual performance, but I think it's kind of secondary effect. They're not intentionally trained to that. So the first thing that we do is take one of these models and we play with all of them to see what's the difference in performance. And basically we have a huge data set of public data that is multilingual, and we have a recipe to kind of continuous pre-training. So the same objective that the model was trained on, we just continue training for quite some time. And what you get is a similar model that is actually better on other languages. So on translation, but what we observe, and again, this is a secondary effect, it's not intentional, is that even when you're trying to do this kind of bar exams or these more complex data sets on languages rather than on English, our model becomes better than the original model on different languages. So I think my claim is that it kind of learn slightly better how to represent the data. And then the phase after that is you go to the instruction tuning. And there what happens is, besides the normal instructions that are open source that all these models use to know how to make dialogue and so on, we curated a very high set of highly curated instructions on translate from A to B, do automatic pause editing from this sentence to these sentences, translate with this specific prompts, giving like glossaries and all of them, and we train on that. And so what you get is basically you get this model to become this much better at these particular tasks. What we observe is that training it for more than one task, saying training it for more than translation, at the same time actually improves translation. So it's being able to do some abstractions. And what we notice is like it becomes better at following specific prompts when you actually teach it to follow that type of prompts. So if you tell them how to expect to receive the glossaries, the style guides, the terminology, then it becomes better. And so this second part is what makes the model even better. Like it's a second jump on the model.
And that is even before you train it for any specific customer or project or client or use case, right?
Yes. So basically that's the open source model that you can find on Hugging Face. What we do then is with our customer data, we do a couple of more iterations on instructions, mostly for domains, but literally these models don't need to be very fine-tuned to customer because again, like they have the knowledge, like the knowledge is all there. They're so big. Like what we use more for the customer is the rec part. So basically getting examples to the customer to kind of find the right prompt, and we see a lot of advantage there. Which means that, all this question of privacy with customer data is trying to get less concerned because you don't have to use the data to train the model.
And then you do the RAG or the customer helps? How involved are customers in this whole RAG process?
No, we do it. So the idea is that the customer just use the platform as they always did.
So you said that you're building this on Llama, right? Llama 2, Llama 3. Is there also something where you built the model from scratch?
Yeah, so that was the second line that I was talking about. So basically we have a European project, again, a connection with academia called TowerLLM, where we're basically building a large language model in different sizes from scratch. And the idea there is to see if you train the model to be multilingual intentionally from zero, do you get an advantage from this model of like take a big model and just do continuous pre-training? And so we're expecting to have the first models like 1B and 7B coming out this quarter. And then we'll share results and make them open source as well.
I think for outsiders, it's hard to understand what researchers mean when they say a multilingual model. I also remember having Cohere on one of our conferences, and they launched their Aya multilingual model. So what's different between a non-multilingual language model and then a multilingual at its core model? Yeah,
I think so. The idea of a multilingual model is you ask them questions on different languages and it answers. And if you look at the model that is non-multilingual, it does that for some languages, but you can see the performance decaying very fast as you move along languages. And the reason normally for that is when it was trained, the data that you've seen has been mostly English. So there's no like good ratio between the different languages pairs. And even when you had like data that is parallel, that can kind of be used to align the representations between languages, it doesn't say it's parallel, it's just it has data. It's just consuming token per token. As opposed to try to get the ratios of the data more concrete, like different languages. And also whenever you have parallel data, tell it that it's parallel data. There's another important hidden factor, which is like have a good tokenizer. So have a tokenizer that works well for different languages that has a very high impact, although it's normally not talked that much about. And that's what Cohere talks a lot about, is their tokenizer.
Also, I think for ChatGPT, when I ask it like non-translation questions, just random questions, I think it always translates whatever I would put in German into English, and then it does what it does in English, and then it kind of machine translates the output back. Like, you know, when I ask it to write like kind of a story about Ronaldo for my kid, then you can sense the output. It's just like it feels translated from English. It doesn't feel like it's been generated in German from scratch.
That's very interesting. I never thought about that. I mean, I know it's definitely not doing a three-step approach on ChatGPT. At least these models, if you take the open source models, they're not. They're just doing it in one go. Maybe it's the way it learns. Maybe it's because a lot of the data it consumed from the web is machine translation for something else, and that's what he's learning for the other languages. I never thought about that too deep.
I want to deep dive on that because it's like it has these like slightly Americanized, somewhat over-the-top things that just wouldn't really be anything that you'd write in German from scratch. Just sounds a bit over the top. Anyway, let's move on. So for TowerLLM, like, okay, so it's available open source, anybody can use it, but then you're using it in your kind of proprietary workflow as well. Like, is there a difference? What can people build on top of it from the open source version?
There is a difference. So first of all, the open source version is not available for commercial use. So you cannot go and sell it. In theory, obviously, you can it, but if you're doing it, it's not legal. So it's mostly for people in academia to do research on top of it and to continue contributing. Then the internal version uses our data and also a slightly different recipe that makes like the performance even better. And that's the one that we sell on our pipelines to our customers. It's the same principle we had with Comet QE. We had the open source Comet QE that won the competition. And then we had the internal Comet QE that was running on much more MQM data, and the performance much better and could predict other things that we use internally for our customers.
When you launched TowerLLM, you made some very bold quality claims. I like that. You know, you compared to Google Translate, DeepL. I think you even ran it, I think GPT-4o. So, like, you know, tell us a bit more about how you, came up with those numbers. What was the quality testing process like?
So one thing is like, I love to do fair comparisons. And one thing I sometimes get upset on the industry is that people make bold claims and there's no way that you can go there and say, okay, show me the data or let me compete as well. And that's why we always try to compete on WMT and all the competitions. So what we did was we participated in Nintendo with the open source model, and the results are there and we haven't access to the test set. We have a bunch of internal test sets that we keep using to compare our quality. So this is customer data that we don't use in training, and that has been kind of like highly curated by our linguists to make sure that the texts are correct. And then basically we just use that to compute Comet scores. And then after Comet scores, we normally get MQM annotations and we look at like what's the actual difference. And so we took that test set and we ran through all the state-of-the-art models back then. So Cloud was not out yet, so the best was GPT-4o, Google, DeepL, our model. So everything we could put our hands on. And what it came out was like our model was the best on zero shot, not for all possible combinations, but on average. And once you put reg, it was by far the best, which is kind of like, reg is an unfair advantage. But I think that the zero shot competition is a moving target because we're all improving our models. So I can tell you that Claude is very good. I can tell that we have a new model, a much bigger model, that beats Claude on zero shot, and it's coming out. You'll see the announcement. But I don't think that claiming they have the best zero shot MT, what's true today is not going to be true in 1 month or 2 months, and that's fine. It's good. It's a sign that we're all moving to learn. I think for me, the model was like, okay, this is the best model that you can find right now, and we're going to keep improving. But don't get stuck on the zero shot, because the advantage of the LLM is not just that it's better on the zero shot. That's already like given. It's everything that you can do on top with RAG. Is the operational simplicity to just one model. There, I think, is the disruption part. But yeah, but that's how we got the claims. And if you want to compare, like our things are open, so you can go to MT compare inval that is on the blog post, and you can go there and put any text there, press a button, and it will run the current version of Tower, Google, DeepL, GPT-4o, and if anyone wants to add their own engine there, just let me know, even API, and anyone in the world can go there and test it. And then they'll see like the Comet QE score and the outputs for each one of the models, because I like to have things visible. And sometimes we're not going to win. You're going to find examples that you put a text there and that other models are going to be better. And that's fine, but you can see it.
So what were some of the things that even TowerLLM is still struggling with, like a few maybe specific error types, challenges, syntactic things, or language, combination issues?
That's a good question. I mean, so it still kind of sometimes doesn't translate the thing correctly or doesn't use like the right tone. There's still kind of the same problem. So I think we're still discovering how to make these things better. And I think it's going to be a lot on like what styles do you pass it to the model. We're still kind of learning how to best use context. So it's kind of the same distribution, but less.
We're just coming like we're going narrower, but we're never quite closing the gap. Yeah.
I'm not 100% sure that these models are going to completely replace humans. You know, they might in the future. These models for a lot of content types are not, okay, done. Put your legal contract taking on the other side. Don't even look and say it to someone.
It's a fascinating discussion. Like there's so much research and so much money being poured into this, and yet we're not quite there. And so the question is almost like, maybe this is not the time and the place, but like it's almost a philosophical discussion. Like, can there ever be without like true AGI, right? Because some of the jumps you'd have to take to make the translation perfect, like it's just too large. Even or you'd have to prompt it to death, and that wouldn't be feasible either.
This is kind of just speculation from my side, but I think that if you split the task into two, and one is translation has a way to replicate what is in one language to the other one and for people to understand, I think we'll get there. I don't know exactly how long. I think we're hitting more on like model capacity. Like, can you look at the entire document, understand all the terminology, than it is on like a fundamental thing. I think if you're now saying, well, but I also want to do transcreation and transform this to an audience, I think that is harder. I think that a prompt that tells you what to do might help, but it's hard to do it fully automated for now.
Those prompts also sometimes, that's just from my anecdotal experience with ChatGPT. You can try it like 10 or 20 times and it still doesn't exactly do what I want it to do, even though like I go deeper and deeper and deeper in the prompting. Like I'm just about that story. Like, okay, write a story for a 10-year-old about Ronaldo, right? And don't make it cheesy. Don't make it say that, he overcame difficulties. I can try this, but even in the 10th version, it still tells me, and then, he scored the goal and he overcame the difficulty. So maybe there's like a limit to how exact you can prompt these things. What about other areas of the translation localization workflow that LLMs can help with beyond just the language conversion part? Are you seeing anything in production right now or using anything?
Yeah, so I think that is the most interesting thing that we're going to see in the industry, because that's really based on everyone's capacity to innovate. They can use any model. So we're using it internally for source correction and for automatic processing. We still haven't put it like to our customers because we're still kind of fine-tuning, understand how it behaves in production, the best way to use it. We have a really interesting pilot on cultural transcreation. So the idea is like, if you're doing customer service and replying an email to a Japanese audience, the way that you write the email in English has to be very different. And so an agent can write as he would normally do in his own English, and then press a button, he gets a new version that is written, that is appropriate for the Japanese culture, and then you do machine translation, and that works very well. We're working on like adherence to style guides, and this is super interesting for the medical domain. So you can take like a huge text and produce a leaflet left that adheres to like all the European Union standards that you have to use. So that is super interesting. We have some early results on translating directly with the markup, so without doing the two-step of removing and putting. And we have a lot of uses for the cut tool. So I think there's a lot of things to explore, and we're definitely exploring a lot of them. I think it's kind of unbounded there. I think it's about creativity. We're launching some of them soon via an API, so mostly the grammar correction and the automatic post editing, especially the automatic post editing with quality estimation, where you basically run MT, identify the errors and say, okay, these are the errors, now fix them. And we're seeing like some really, really good results with that.
Would you call this also like agentic machine translation? There was this post by Andrew Ng recently that kind of caused a bit of a stir there on LinkedIn and Twitter.
I definitely think that agentic might be the future. So what we're using is more of a pipeline. So it's kind of like, call this module, we call this module, call this module, call this module. I think agentic is more, you give it a goal and an ability, and they decide which model to call afterwards. So that is definitely something that we want to explore. We haven't started yet. I think that there's still a lot to collect before you go to those flows. But I wouldn't discard it if in a couple of years or even next year, there will be some interesting solutions using these edges, because intuitively it looks like a really good solution.
And would you call xTOWER an agent? You released a paper just a few days ago, and I think the title was xTOWER, a multilingual LLM for explaining and correcting translation errors. And then let me just read from, I think it's the abstract. It says Tower Base is designed to provide free text explanations for translation errors in order to guide the generation of a corrected translation. So where would such a free text explanation be helpful? Is that for another automated prompt or for a human to look at it? And what is xTOWER?
Well, so that is really cool. So the idea was, once you have an error, so you have QE detecting errors. And by the way, state of the art for QE is still XCommat, which is not LLM in the way that we talk about ChatGPT style. It's a large language model with a discriminative layer to discriminate where the errors are. And we still haven't managed to get the same results on identifying the errors with a generative model. We probably get there, but we haven't. And by the way, there's this interesting debate internally, like, should we use the same model to detect errors than the model that generated the text? Is there some bias there? Should you use two different models? So it's a very interesting research question. Now that you have the errors, what we start wondering internally is like, okay, but can you kind of explain what the errors are and also suggest a correction? And the answer is yes. And so we start training Tower for that. So basically, like, it looks at the output of the errors of QE and tells you like what he thinks the error is about in a descriptive way. Now there's two ways you can use it. You can use it on the CAT tool. So the translator is not only seeing the underlying of the error, but once he hovers, he says the explanation. So it makes it easier for him to correct. Or you can use it as a prompt to pass it to automatic processing to say, by the way, these are the errors, and this I think is the error. And then the model does better with this. So one early experiment that we did that was really interesting, we haven't productized it, was if you get a customer complaint about the translation, can you just use it on the prompt and say, okay, translate this again, knowing that the customer complained about this. And the early results were kind of like very positive, but again, these tend to be a lot of like cherry pick examples. Oh, for this example, it worked well. The way we like to work at Unbabel was like, no, let's build a proper test set, see what's the performance, when does this work or not work. Let's understand this before we put this in production, because once you start passing a massive amount of words, it can go very bad. But the early results are super interesting. That's why I'm so excited with LLMs. It's like, I have a lot of problems that were very hard to solve, and you just throw it at them, and it's promising.
So kind of pipeline. So you have, okay, MT, then there's maybe a score, then the LLM almost verbalizes the score, makes it into human readable language, and then you ingest that human readable language back into the LLM to then do an automatic change of it, right? So I guess that, yeah, you can call that agentic. And then at some point, maybe the human will still read the thing, but yeah, it's a lot of steps.
The biggest difference I see between the two is the following. So we're talking about internally about AI-only pipelines. So it's a pipeline that just says like source correction, MT, QE, automatic pass editing. And then the question is like, now what? Imagine that the quality is not good. Do you do like another QE and another APE? Like, do you do a maximum of 3 loops, a maximum of 10? I think that once you stop hard coding this and you say, well, I have 4 agents. One is one that does translation. The other one is look at the errors. And by the way, we can do a lot on the errors. I can talk about these. The other one goes there and corrects. But then you set the goal to have a translation has a minimum of 99 MQM. Then they decide if they should call each other more or not, or stop on the budget. So it's kind of like, instead of having hard code on the pipeline, you transform this and say, here's the goal, and I want to achieve this max MQM with this budget. And now you do whatever you want. But it's very similar, like an agent that does QE versus a model that does QE. They're not that different. It's just like the interaction between both of them.
You want to make sure you set a limit, otherwise it's stuck in this loop until it reaches 99 and does a gazillion iterations. Can we just talk about kind of the language coverage challenge, right? So Google just went out with 100+ new target languages, and like, how do you decide which languages to cover from a B2B setting? And then like, how comfortable do you have to be to maybe launch a language? I mean, Google seems to now have used these LLMs to go much more low resource, and they're launching it in production out there. I think DeepL may be a little more cautious, right, when they launch a new language. So what's your approach there?
So one thing is, I've seen a lot of people concerned with LLMs because it's going to be bad for low resource languages. Again, I think that's a fake argument. It's exactly the opposite. Because the abstractions are much better, so you need much less data to start doing low resource languages than you needed on the previous neural MT model. So it's just going to get better. I mean, so we basically are focused on like where are we getting demand from customers. So if we have a lot of push for a particular language, then we open it. Otherwise, we just keep with ours. Because it takes effort to open a new language. You need data, you need to add it to the model, you need to have a community that can then do the post editing, you need to have a community that can do the MQ annotations. So it's basically like on demand or a strategic decision, like we want to tackle that market, and for that market we need language ads. So let's preemptive add that language and then take it to the market. We don't aim to have 100 languages because I think that's a Google goal, and they have very different goals than we have with machine translation. They have a completely different set of resources that we have to use on our availability. But if we need it for a particular customer, particular use case, we can put it pretty fast. So that's how we operate.
Talk about your resources, human resources. Like, how is the kind of hiring environment at the moment for anything like AI experienced engineers in Europe? I mean, you have a big location in Lisbon. I think you're also in the US. Like, how do you see that?
I mean, so I think we've been very lucky at Unbabel because our presence in academia since the early days, and because we pretty much know most of the professors that are working on NLP and translation, either at a very personal level or very close, we get this pipeline of students that when they're leaving, they consider Unbabel because they look at Unbabel. If you go to a conference like ACL and you see who's publishing papers on this area, besides the big players, you see a lot of Unbabel. So we get a really good reputation. So I used to joke that it was easier for us to hire AI talent than it was to hire just engineering talent because the perception of the market of our quality was so dispersed. So it's not hard. It's becoming very expensive, especially for like particular subgroup and experienced people. But so far we can't absorb everyone that we could hire if we could, unfortunately.
Good problem to have. I want to close on kind of a general discussion around LLMs. I mean, we've been waiting for ChatGPT 5 for a long time, right? Then some of the announcements that, for example, OpenAI made around the audio, or seems like they were more kind of demo level and nobody has access to them yet. Like, do you see this as kind of an indication that the broad category LLM, that progress is a bit slowing? And then, you have this discussion like the Jan LeCun and Cholet camp versus like I don't know, there was this guy on the Dwarkish podcast recently called Leopold Aschenbrenner, which like went totally the other way. So I guess my question is, where do you sit on this like acceleration of LLMs and AI progress debate? Where you're there?
I mean, I think that LLMs can't reason. So there's a second level to go to AGI or whatever AGI means. I think there's still things to go on LLMs, and LLMs are becoming better now. ChatGPT caught everyone by surprise because it was a huge step change to what could be done before. You were not used to be able to prompt a model with natural language processing and get good results. So that was not as good. And so after that step change of ChatGPT and GPT-4 right afterwards, that was much bigger, everything has been incremental, which is normal. So I think we're going to keep seeing incremental. I think this multimodal is a big change, although they're not calling it 5, they're calling it 4.0, or it's a big change, and it also kind of increased a lot the amount of available data. So I think you're still going to see some changes on this. But yeah, I think you're not going to see a step change until something changes from the current architecture, the current model.
So that kind of transformer kind of foundational, that'll get us to very exciting places, but it's more around the fine-tuning, the nuancing, the finding new ways of using it like you're doing at Unbabel, but not really like another quantum leap and the thing is going to go rogue. Or
that's my perception. I don't believe the rogue part, so I'm not a believer of that side. I'm not sure if it's like the agent part is going to make these interactions and then you can build on top of that. If it's going to do like a second level, like a type 2 reasoning on top. I don't know exactly what's the potential solution. There's a lot of things being talked, but I think there will be something different. I think LLMs are kind of like, LLMs will become sort of a programming language. So we can all use it. It gives you like this amazing abstractions and the ability to do tasks, but they're not the end per se. Then you're just going to build stuff on top of them, like you do on the normal programming languages.
It's good for the linguist people like myself who can't code, so I can just use my natural language and build something if I have an idea.
I was surprised with our linguists, like they've been doing amazing stuff because now they're empowered. So before they could do regular expressions, and that was kind of like the most. And right now they can do amazing stuff. So it's really, really interesting.
Awesome. All right, João, on that note, thank you so much for taking the time today. This was great.
Thank you. Thanks a lot for it.